in confidence intervals. And now we're doing the same thing with the mean. So the previous chapter we talked about x hat or p hat and x bar. Now we're doing the confidence intervals for each of those. Just like the other one, we will primarily do it on the calculator, but I do want to show you a little bit about it as well. So if I said pennies minted after 1982 are made from 97.5% zinc and 2.5% copper. The following data represent the weights of 17 randomly selected pennies minted after 1982. So treat this data as a simple random sample. Estimate the population mean weight of the pennies after 1982. What would you do to find the mean? Okay, you guys do that. Find the mean for me. What does it add up to? And if you divide that by 17, you get about 2.464-ish. Talking about grams. So that's our average, our mean. So, if I had a different sample, would I get the same mean?
No.
No. So again, a different sample will give us a different mean. So if I want to be able to predict it, I need a confidence interval. I can't just say the mean will be this. I need to say the mean will fall between these numbers. Unlike the distribution for the proportion, this one isn't the normal distribution. It actually follows what's called a T distribution. T, it's very similar. It's our sample mean minus the population mean divided by S over the square root of n. We are primarily going to use our calculators for this. There is also an entire table that gives us T values. So we're not going to do this calculation very much. The other thing that you really do need to know for reading the table, degrees of freedom is always one less than your sample size. So this one had a sample of 17, so it would be 16 degrees of freedom. X bar represents sample mean, S is the sample standard deviation. When we're looking at this T distribution, it is different depending on the degrees of freedom, which is basically saying it's different based on your sample size. It's centered around 0, just like our normal distribution, and it's half on each side. It is just going to get closer and closer to 0, just like our normal distribution. So it's very similar. The difference is that there's a little more in the tails than there is in a typical standard normal distribution. So there's less in the center and more on the tails. It looks something like that. So you can see the normal curve is this top one. This T distribution, it changes depending on your sample. So if the sample's really big, it looks like a normal distribution. As the sample gets smaller, it's a little bit less normal, but the same general shape. All right, notation. Everybody pay attention here. These are the things that we need to know as we're moving forward. We are going to see T alpha a lot. Just like Z alpha is area to the right, T alpha is area to the right. Okay, we're just using a T value instead of a Z value here. So if I wanted to look at this one, we're going to practice understanding this. Find the T value such that the area under the T distribution to the right of the T value is 0.2. So T distribution, it looks like a normal one. Area to the right, 0.2.
So we'll find 0.2, similar to the Z chart in 5, we'll find 0.2 inside the chart, not on the outside. Because it wants what's in there, not the.
Yeah, so this one is set up just a little bit different. We're not using the normal distribution this time. Assuming 10 degrees of freedom. Another way you might see this is T sub 0.20. So we need to go to our T distribution. If you look, that is table 7. It's on the back of your normal page. All right, so our T table, set up a little bit differently than the normal one. Down the side it says DF. What do you think that means? Degrees of freedom.
Yes.
So I want 10 degrees of freedom. Okay, so I'm going to row 10. Across the top, it gives us the area in the right table. So this one is actually a little bit easier to read. I'm going to row 10, and I'm looking for the column that is 0.20. So that's this T value. So it's just set, the probabilities are really across the top in this table. All right.
So for T distribution, we don't have to subtract 1 off of the 15? I don't know.
Oh, you're an example ahead of me. This one.
No, I thought I was behind you. I don't know. I was looking, I remember we were supposed to subtract.
Yeah, if I need to find the degrees of freedom. I didn't have to on this one. Because I told you the actual degrees of freedom. Now, if I had said there were 10 in my sample, then it would be 9 degrees of freedom.
I see. So 10 in the sample is 90.
Yes. All right. I want you guys to try this one. This time we wanted 0.1 to the right. We're looking for this T. It told us 15 degrees of freedom, so you go to the row 15 column, you're looking for 0.1, and you should get 1.341. And it looks like we did just fine with that. All right, the downside of this table, the degrees of freedom, I give you, 1 through 40, but after that, I only have 50, 60, 70, 80, 90. I can't give you all of them. That would be a really massive table. Also, the probabilities at the top, did I give you every single probability? No. So we're going to be fairly limited on what we can use this table for. If I give you like 82 degrees of freedom, your best guess would be to use 80. If I give you degrees of freedom that's not on here, you use the next closest and go from there.
We wouldn't use the equation?
That won't give you, that would just give you the T value, but we're talking about probabilities available. Okay, so we use these T values to construct a confidence interval. In order for that to work, we have to have a simple random sample. Same criteria as we've been seeing, sample has to be less than 5% of the population. And it has to be normal or the sample size is large. How large is big enough to be considered normal? 30. So, still has to be less than 5% of the total population, and either sample is bigger than 30 or the population itself is normal. So this is how we calculate the confidence interval. It's centered around the mean, just like our other one was centered around p hat. So it's our sample mean plus or minus the T value times S over the square root of n. On the calculator, so I'll show you how to do both, but we will be going to stat, test, let me check, let me see the names. Number 8. It's called T interval. So when we do it on the calculator, that'll be the process. I want to take a minute and do this one both ways. We're going to do it by the calculator, and then I'll also show you that we get the same answer by hand. So the data shows the reported miles per gallon of a 2011 Ford Focus automobiles for 16 different owners. Treat the sample as a simple random sample of all 2011 Ford Focus automobiles. Construct a 95% confidence interval for the mean miles per gallon. So, first thing we are going to have to do. Did I give you the sample mean or any of that information? Okay, you need to enter all of this into L1. Did everyone get that entered in L1? So now we are going to go to stat test number 8. And then it's going to ask you some questions. Input. Your options are either data or stats. If you highlight stats, it asks you questions. X bar, standard deviation of X, N. Do we have those things? No. We are entering ours based off data. We put in the data. Then you have to tell it where you put your data. So list, it should automatically say L1. If it doesn't, fix that because that's the list where we entered the data. Okay, then your frequency. Everything should have a frequency of 1 right now. We're not doing any weighted means or anything. Then it asks for C level. What do you think that means? Confidence level. It has to be as a decimal, so 95% confidence would be 0.95. All right, everybody should have those entered. And then you go down to calculate. And we should get 35.246 and 38.354. So that is my confidence interval. 95% confidence. Does everybody have that? It also asked me to interpret, which is writing a sentence. So this means we are 95% confident. The mean, F bar, we're talking about a mean. We were talking about mileage on this. Is between 35.246 and 38.354 miles per gallon. Another way of saying it is if I had 100 different samples, I would expect 95 of them to get a mean between these two numbers. All right. Is that okay? I do want to show you how we do it by hand. I think I left a blank slide after this. So we do have to use our calculator for a bit of this. I guess we don't have to, but I don't really want to calculate standard deviation by hand for this or anything. So our formula for doing it by hand is X bar plus or minus T alpha over 2 times S over the square root of it. We need to use the calculator to get some of these things. The X bar, the S, the N, I think it told us we already know that was 16 different automobiles. So if you go back to stat, calculate one variable statistics, remember how we used to? It tells us the mean is 36.8, standard deviation is 2.917. Did everybody get that? All right, so we use our calculator for those. Now we need our T alpha over 2. Okay, we are talking about 95% confidence. Okay, so if I have 95% in the middle, how much is left for the ends? 5%. If we split that over 2, so we're looking for 0.025, how many degrees of freedom do we have?
50.
Yeah, it's n minus 1, so 16 minus 1 is 15. So you're going to row 15 and 0.025. So what do we find for our t value? 0.13. Okay, so that's all the stuff we need. Now, x bar, so 36.8 plus and minus 2.131 times 2.917 over the square root of 16. So you plug that in, make sure you do your minus first. If we round it to 3 decimal places, I get the exact same thing I had the first time. It does give us a few more decimal places, but if I round to 3. Any questions there? Okay. So let's try a couple more. I'm constructing 99% confidence interval around the population mean weight of pennies minted after 1982. So we can do this by hand or on the calculator. Let's go ahead, for purposes of our example, I'll probably do both, just to make sure you guys understand both ways. No matter what, where do we need to begin? Well, if you want to calculate the mean, yeah, at least enter them in L1, because we're going to need standard deviation and everything even to do it by hand. So if we are going to build our confidence interval by hand, you would have to use your calculator to get your mean and standard deviation. What do we get for the mean?
2.464.
And our standard deviation is 0.0177. Our n, how many did we have?
17.
Okay, so we need our T alpha over 2. So if we have 99%, there's 1% left over. You split that in 2, T of 0.005. How many degrees of freedom do we have? 16. It's always n minus 1. So if we looked at our table, 16 degrees of freedom, 0.005, 2.92. Okay, so then if we use our formula, so we're just doing the same one that we did here. So x bar 2.464 plus and minus my t 2.921 times s 0.177 over square root. So I did 2.451 to 2.477. So I'd be 99% confident the mean weight fell between those values. On your calculator, if you want to do it, so you go stat, test, number 8. This one is again based off data, but if I did have the stats, I would just have in the problem the mean, standard deviation, and n, and plug them in. So nothing big there. The only thing we really need to change from the last one is our confidence interval needs to be 0.99. And we get 2.4516 to 2.4767. Are those pretty similar? Yeah. So in general, calculator is fine unless I specifically gave you a problem and asked you to do it by hand, but I probably wouldn't do that very often. We should be able to do either way though. Any questions there? Okay, the last thing I want to talk about, just like yesterday, we had some where we were estimating how big our population had to be to fit in a specific interval or to have a certain level of confidence. This has its own formula for that. Ironically, it uses a z value, even though we're looking at a t distribution. Just take my word for it. That's the formula. You should use it without questions asked. We always have to round up on these. This is again given on the formula sheet. So yesterday we talked about that first bubble under sample size. This one is the second bubble if we're estimating the population mean. It tells us how big our sample should be. So we just have to be able to use this. Let's try one. So we again consider the problem of estimating the miles per gallon of a 2011 Ford Focus. How large of a sample is required to estimate the mean miles per gallon within 0.5 miles per gallon with 95% confidence? So our formula, N is the alpha over 2. So again, that's just from this, times S divided by E. All right, we do have to have a sample for this. So from example 4, what was the standard deviation we had in example 4? That's when we were talking about this set. 2.917. So you would have to have a data set or a population that you're basing that off of. Okay, what is my E? E is our error. How close do we want it to be? 0.5. My confidence level. Okay, that's used to find this z alpha over 2. So if you look at, this is a z, so we're on our normal table. Everybody flip to the normal table now. Kind of annoying going back and forth. 95% confidence, so that's 5% left over, or it means 0.025 is the area to the right. So remember, if there is 0.025 here, how much is over here?
Oh.
Yeah, the other side would be 1 minus that. So it would be. So you're looking in the table for 0.975 and seeing what the z value is that matches that. So if we look at 0.975, that is at 1.96. This is one that's also common enough. It's at the bottom. The 95% does tell you is 1.96. So now we plug these in. So 1.96 times 2.917 over 0.5. So it's supposed to have a square on it. And I get 130.75. So how many would we have to have?
131.
on these, it does make a big difference how much you round your standard deviation. Like if I had rounded my standard deviation to 2 decimal places, I would have had a different N, it's like 132, so they're close, but just make sure that I see the numbers you're using. So if it's just a difference because you cut more decimal places on your standard deviation, that's fine, but I have to know what you used for your standard deviation to check that.
So I'm kind of like all that except for when you wrote on the graph, like I don't understand where the .025 comes from. Like I'm not good at that.
Okay, so it was 95% confident. So that means, if you think about the normal, we want 95% to be in the middle. So that means 5% is left for the 2 ends. So that's .025. That would be .025. To look it up from the table, you have to do area to the left. So 0.95 plus 0.025. Any other questions? We got through that quicker than I anticipated. So, you have some time now to start your Chapter 9 homework. We have a work day tomorrow, so Chapter 9 is due on Friday. And then we are at the end of the unit, so we'll be getting a study guide.